For topic two, we're still going to be dealing with square roots. So we're going to solve radical equations that have no real solution. So let's talk very briefly about something that we learned in the past. Okay. So at the start of this unit on radicals, we learned something called the principal square root. Okay. So when you have the principal, honestly, can't remember if it's AL or LE, it doesn't matter. Principal square root, we had a situation where A and B are non-negative, meaning they're zero or they're positive, and we would have b squared equals a, so the square root of a was b. Okay, so that was the principal square root. And the big thing you have to understand here is that when you're dealing with a principal square root, a and b have to be positive. Okay, they cannot be negative. All right, so the radicand can't be negative, and on the flip side of that, the result can't be negative when you're talking about a principal square root. Okay, so keep that in mind. Okay, now when we're dealing with solving a radical equation with no real solution, it may show up right away. Hopefully your brain kicks in and you're like, oh, that can't happen. But if not, just solve it and then check your answer and things will fall apart for you. Okay, now a radical equation has no solution when the principal square root is equal to a number less than zero. So again, when you're dealing with the principal square root, a and b have to be non-negative. Okay, that means they can't be a negative. They have to be zero or positive. Okay, so the directions here say solve each equation, check the solution, and you can see on the surface these equations look very reasonable. There's nothing crazy about them. Okay, so the steps for solving radical equations, remember, would be to isolate the radical. Okay, well, for part A, we have the square root of 5x minus 1, and then we have plus 7 equals 5. So I want to isolate the radical. In order to do that, I need to deal with that plus 7. So I want to subtract 7 from both sides. Well, 7 minus 7 is 0. 0 plus that radical is just the radical. So I get the square root of 5x minus 1, and that equals negative 2. At this point, there should be a red flag. We have a square root equal to a negative. Principal square root can't be negative, okay? So we know right off the bat this isn't going to work, okay? So if you catch this early on, you could just be like, well, there's no real solution here. But let's go ahead and finish solving this so you can kind of see how this works out if you don't catch this right off the bat, okay? So at this point, we would want to square both sides. Once you isolate the radical, you square each side. So we're going to square the square root of 5x minus 1. We're going to square negative 2. Well, when you square a square root, they just unravel each other, so you're left with radicand. So on the left, we would be left with 5x minus 1. And then on the right, negative 2 in parentheses squared is 4. Okay? Now, I would want to isolate my 5x. The issue there is going to be that minus 1, so I would move it by adding 1 to both sides. Negative 1 plus 1 is 0. 0 plus 5x is 5x, and then 4 plus 1 is 5. Looks great so far, right? Like nothing crazy. Now, I need to undo the multiplication of 5 and x, so I would do that by dividing both sides by 5. 5 divided by 5 is 1. 1 times x is x. 5 divided by 5 again is 1. This looks reasonable. We're like, this is a fantastic answer. What is wrong here? Well, let's see what we have, okay? When we check our solution, we're going to check x equals 1. Well, I get 5 times 1 minus 1 plus 7 equals 5. Well, 5 times 1 is 5. 5 minus 1 is 4. Well, the square root of 4 is 2. 2 plus 7 is never going to be 5. 2 plus 7 is 9, which does not equal 5. So we have one of those extraneous solutions. We have a situation where we solve the equation. It looked beautiful. Getting a value like x equals 1 is magical. We're like, that's great. That's a nice answer, but it just doesn't satisfy the equation here. So we would have to say there is no real solution. Or you can just do the little brackets and leave them empty. Okay, let's look at part B. Okay, so for part B, we have the square root of 2x plus 3, and then we have plus 8 equals 6. So again, our goal is to isolate the radical. We need to do that by subtracting 8 from each side. Well, 8 minus 8 is 0. 0 plus the radical is just going to be the radical 2x plus 3, and that equals negative 2. So again, red flag. Okay, we have a radical, so we have a principal square root that equals a negative. That can't happen. Remember, A and B have to be non-negative. But let's go ahead and just finish solving so we can prove it to ourselves. Okay, so at this point, we want to square both sides. Well, when I square a square root, they just undo each other, leaving me the radical. So I'm left with 2x plus 3 equals 4. Negative 2 in parentheses squared is 4. I want to isolate my 2x, so I would subtract 3 from each side. 3 minus 3 is 0, leaving me with 2x on the left and then 1 on the right. And then finally, 2x, I need to undo that multiplication, so I divide both sides by 2. 2 divided by 2 is 1. 1 times x is x. And then 1 divided by 2 is just 1/2. Let me plug my computer in. It's about to die. There we go. Okay, so we get x equals 1/2, but we have to check our solution. So we're going to check x equals 1/2. So we go back to the original equation. Anywhere you see an x, plug in a 1/2. So I get 2 times 1/2 plus 3 plus 8 equals 6. Well, 2 times 1/2 is just 1, and then 1 plus 3 is just 4. So we have the square root of 4 plus 8 is 6. Square root of 4 is 2. And 2 plus 8 is never going to equal 6. 10 does not equal 6 in this lifetime or the next, okay? So we would have to, again, say there's no real solution here. So no solution. And instead of writing out no solution, you can write the curly brackets or the curly braces and just leave them empty. That indicates to the reader that there's no solution here. Okay, so again, be on the lookout. I kind of warned you about this at the beginning of this worksheet. Be on the lookout for those extraneous solutions, okay? They will pop up from time to time.